In this video, we are going to discuss how amines can be prepared by alkylating nucleophilic nitrogen atoms. Procedures follow general two-step strategy where we first react a nucleophilic nitrogen and then electrophilic carbon attached to a good leaving group to create a carbon-nitrogen bond and use reagents to form the final amine product with alkyl groups attached. Many procedures exist, but they all use the fact that nitrogen has an available lone pair. One method we'll discuss is the alkylation of ammonia, where ammonia reacts with haloalkanes. The mechanism is as follows. We first start off with our ammonia and haloalkane, in which nucleophilic nitrogen of the ammonia attacks the electrophilic carbon of the haloalkane, kicking off bromine in a typical SN2 reaction. This then creates the weakly acidic ethyl ammonium bromide salt, which can be deprotonated by the same weakly basic ammonia we started with, to establish our primary ethanamine and an ammonium salt. You may notice that we re-established a nucleophilic amine group that can once again attack an electrophilic carbon. This leads us to the problem of subsequent alkylation, where if we add more equivalents of haloalkane, we will keep alkylating the initial ammonia molecule until there are no free electrons on the nucleophilic nitrogen, giving us a final mixture of primary, secondary, tertiary, and quaternary amines and ammonium salts. This further alkylation makes it hard to stop at a specific desired amine and is therefore an inefficient way to prepare amines. So how do we create amines more efficiently? We can use a synthetic procedure of Gabriel synthesis where we use a commercially available phthalimide to indirectly create a primary amine in a non-reductive way. The procedure is as follows. We start off by forming the amide of phthalic acid phthalimide. Once we have our phthalimide, you may notice that the hydrogen is sandwiched between two electron-withdrawing groups, carbonyl groups. This increases the acidity of the NH group from the average pKa of 22 to a pKa of about 8.3. This allows for deprotonation with the mild base acting as a carbonate ion. The resulting nucleophilic nitrogen can proceed as before and add to electrophilic carbon, kicking off bromine and attaching the R group to the phthalimide. This amine within the phthalimide can then be freed by first acidic hydrolysis to create an ammonium salt and then deprotonating it with base to create our final primary amine. Our final result is an okay yield of a primary amine, which is much better and more efficient than alkylation of ammonia. Keep in mind that these are only two methods of which we can create amines, and other electrophilic carbon species can be used to make different amines.